Hello, good afternoon, ladies and gentlemen. And now I will give a little bit an insight about the Fraunhofer activities for mobility of the future. And as we have learned, mobility in the future are not also the future for cars. We have a lot of more contributors for our mobility. I've subdivided the presentation into 3 short points: drivers of change toward smart mobility and Fraunhofer Smart Mobility R&D, and 2 examples for solutions and a short outlook. Now to the drivers that we can see here. The most important driver is the demographic change, and most of you know this. Not only the population growth, also the urbanization, the aging society, other functions for drivers, and the different development in the different parts of the world. As the next, the growing complexity, the interconnected supply chains for production of mobility systems. As you know, at the present time, we also in Germany and in Europe have problems by chips, by microelectronic parts for cars, and the global sourcing and the competition. And we have new consumer interests. The young people, life cycles, or what we can do, e-bikes. The mobility as a service in general is the main challenge, and not only what I said, the cars. Sustainability is overall a requirement for all systems. And as you look to the technology, you can see artificial intelligence and digitization is a key precondition for automated and connected drive mobility. And the optimization, smart service as a service, and the last big bang of a requirement to our Fraunhofer institutes was, can the car be in the future, the personal cell in the car? Also, can we use it like a small hospital to detect the situation of the driver and his actual situation, also dependent from his reaction and others. And we have alternative drives and fuels, battery fuel cells, alternative fuels, and I will later give a little bit deeper insight. We prepare at the present time by Fraunhofer a research factory for battery cells, and we prepare also a research factory for fuel cells. It's not so easy in a country like Germany with a high level of salary for the workers to produce in the competition to Asia, for example, battery cells. But we will realize this in a new production system and new technology approaches. And energy technologies is the next technology driver. As you can see, the urban air mobility is a new driver. Also in Germany, we work also Fraunhofer together with some companies. We call it the virtual mobility. And we will see in the next time that we have also for this a reality lab. And the policy, what you can see here, is the sustainability goals from the European Union, the emission reduction, the innovation investments in infrastructure. And as you know, today we have a step by step, we got a high number of electrical cars, but the infrastructure is behind the development of the cars. And safety and security, last but not least, is a very special point which we have to consider especially for autonomous drive in the future. And here, the European strategy for sustainable and smart mobility. As you can see, we have 7 special goals here. The reduction of carbon dioxide emissions by 55% to 2090, and 30 million zero-emission vehicles in operation we should have in the next years. the doubling of high-speed rail traffic, the reduction of the road fatalities by 50%. We reduced this in the last years very strong, and large-scale deployment of automated mobility and twin, green and digital transitions is a need for us, and the interoperability, infrastructure, IT, and intermodality. The intermodality means the seamless transfer from different mobility systems. And now to some Fraunhofer activities. As you can see here, we go a multidisciplinary way. We have in Fraunhofer 75 institutes, and 30 of them work in this field of smart mobility, and the different Fraunhofer groups, the ITC sector, the light and surfaces, especially for sensors for detection, the materials and the components for lightweight construction, for safety, microelectronics, and production technologies. And we have designed in Fraunhofer, together with the German and European automotive industry, a lead market for the mobility sector, where we work in these different regions, as you can see here. What I mentioned, the battery cell production, we have a project about 700 million euros in Münster in Germany, where we build up 3 different production lines for research in different sites and in different numbers and in a different technology deep. And this is for industrial partners to try out her own products in the future and the product technology for the products in the future. And the fuel cell production, in this focus, we look for a roll-to-roll production for the different fuel cell designs, and also the material development here is a strong focus in this research field. And here a best practice example from our smart intersection communication with partially automated vehicles for a trustworthy area that we can see here. And the challenge is that we have a lot of different users in the mobility on the street, for example, from only a person with with nothing around his body for the safety, and until to a car with different speeds. And the question is, how can we maximize the safety and the efficiency? And what we do here in the solutions that you can see here is the automatic detection by video, radar, and LiDAR. In the future, we want to use here also quantum sensors. We work very strong about quantum sensing for detection in this field in the future. And detection activities outside the field of the view are very important, and bring the signals back via internet to the car what is in action. And in general, we want to build up in this way a trustworthy and safe data processing system for about our mobility data space, and we use it then for the real mobility in the city. And on the end, we hope that we can design a digital map that help us, the semi-automatic vehicles, to navigate in the future as an intermediate step until the autonomous and connected mobility. And the second example is here in cooperation with our Israeli partners, and especially here in Tel Aviv, in Jaffa. As you can see, a lot of young people, and not only young, use the e-micromobility by an e-kick scooter. And there are a lot of advantages, as you know, lightweight transportation. We have the chance for a short distance to use this, very, very flexible also. And the Tel Aviv and kick scooter system, what we have here, benefits for sustainability, and what you can see, the convenience in hot climate is also an advantage. And we have results from the study that we reduce the accidents also in future, but there is necessary to do something. As you can see, sometimes the people with the e-scooter have a relatively high velocity on the walking way. And for this, we have also additional needs in the future for reducing the accidents. And the results in this case, which you can see here, are regulations for accident prevention and anti-cluttering. And this is realized here by the city government. And we look for a seamless integration into other modes of mobility, for example, with the railway or by car or buses or others. And the impact assessment on the city traffic and the safety is very, very significant. And a best practice for, we call it SEC for cars, security for connected automated cars, which we have also in research and in tryout in Germany here, is that we use an IT system and data exchange of a core, as the core of the smart mobility in our system. And as you know, a high reliability and a high safety for function is necessary. For example, as you know, we have now problems with what I mentioned with the chips for the cars. And now comes a company and offered new chips in the 2 nanometer until 5 nanometer level. But the automotive industry cannot use them because the reliability is not so high. We buy circuits in the dimension of 12 until 16 nanometers. It's a very interesting thing. And this we also have to bring in the complete IT system for the autonomous driving here. The security is the first and the main important question. And we have now to transfer this solution in a real environmental in Germany, and the first results we have, and I think we will bring it to a complete use system in a city in Germany here. And a short outlook on the end, the mobility innovations through quantum technologies. We do a lot in Germany and also in Europe in quantum technologies. We build up in Germany now 5 hubs to develop quantum, also qubits as basic for quantum systems. And these qubits we can use in the future for sensors, but also for quantum communication. As you know, quantum communication, for example, based on photonics, you cannot hack. You can only interrupt the communication. It's very, very important for the future, and very hopeful approach that we have here. And we work about the quantum computing, and this is very important that we get very fast results from the models also for autonomous driving in the future in general here. And last but not least, we have in Germany from Fraunhofer a very, very interesting conference to quantum technologies. You can see it here, and I invite you all very, very warmly to this conference. Thank you so much.